guys are relaxed, ready to go. Okay, it's wonderful to be here. I am Siamak Tavalai. I'm the Chief Platform Architect at Google Infrastructure. And with me, I have Silvius.
Hey, I'm Silvius. I'm a software person. I'm responsible for the compute platform software for Google data centers.
Very good. We have a nice program for you today. I hope you enjoy it. We will first talk about how Google is participating within OCP projects. Then we talk about what we call the flywheel of success and how we integrate different technologies into eventual products. And then collaboration with OCP is important. And we end with conversation about a modular system that we're working through. And we introduce some of the workshop items we have for tomorrow. So as you know, OCP projects are very active. There are very many projects working, and Google is participating in every one of them. You can have the list of them here. They're active. We have 2 incubation committee members serving as representatives for server project and security project. On the floor, showroom floor, you should see a lot of Google faces. Please introduce yourselves, have casual conversations, ask detailed questions if you like. I hope that they are helpful. Today, I met a lot of good people, and we had great conversation. We are basically trying to cover multiple aspects of computer hardware and architecture that we're employing into our data centers, and we're helping others be successful as well. So the core of the conversation today is about what we call DC-Stack. It's a data center-ready integrated system, which is a convolution of a set of software lying on modular hardware system. We've shared this flywheel of success with you guys perhaps before. Within OCP, what we're trying to do is really provide an environment for people to integrate technologies from perhaps external consortia, add software and firmware, put them into nice enclosures, add test and validation on top of all of that, and eventually produce products that are useful for various data centers, hyperscale data centers, enterprise data centers, or edge data centers. To do that, we take work output technologies from various OCP projects. There are a number of companies involved to make all of this happen. But none of these things will happen without people. So we need a lot of collaboration from individuals to spend some time, sometimes outside of work hours, to help contribute to the activities we do with the community. So the motivation for this modular hardware came from the fact that my colleague Silvius gave us a challenge. And what was the challenge?
So I'm responsible for 2 things. One is to develop software, and another one is to develop systems that just work at very large scale for a very long time. Whether I buy them or build them or mix and match, whatever it is, in the end, they have to just work. Everybody on top of this infrastructure, and this is internal Google services that you see outside as search or Gmail or YouTube or so, or a public cloud, everything has to just work. But hardware is hard to just work, right? So, yeah, because there is a combination of there are device vendors, then there are system integrators, then systems come into data centers and so on. So we want to get to a middle ground where the systems flow more freely and hardware is easier to add. and non-differentiating roadblocks are removed. So this is where we want to get to. We want to get to a point where it's just easier to build and buy and bring a mix of hardware that is good for business in general, for everyone, and to do that with low effort and quickly.
Right. So that was the challenge that Silvius gave us. And we thought that how could we make it win-win for everybody, not for Google, but also for our partners, for our suppliers and stakeholders. So basically finding a way for good solutions to find their way into the data center as fast as possible really will provide a win-win for everybody. Solutions find their customers and people get paid for it, and that's nice. Another concept was that if suppliers work on a particular solution, hoping that perhaps one of the adopters eventually adopt the solution, there's a hit and miss if only they are targeting one customer. So the environment that we'd like to provide here is such that when supplier is thinking about building something, the specification is clear enough that more than one customer might like it at the end. It could go to Google or Microsoft or Facebook or any other OEM or other end users. So that was the goal. So that is the win-win flywheel of success conversation that we have. And for that, OCP is a great place. We have established legal framework for collaborating even between competitive companies. And then providing an environment for subgroups under individual subprojects and under individual projects to form and bring some contribution. The contribution could be project management, the facilities to perhaps provide reference designs, fund the project, bring in some new technologies. Once you bring something in, then you're welcome to support and contribute.
So let me dig in a bit into it and kind of explain what it means. Win-win, I think, is easy to, everybody agrees to. But I want to talk a bit about the problems that we're seeing to align on. Not everybody's seeing the same problems, right? So this is a Google perspective. The solutions that we're going for are not specific to Google, though. We're looking for something that works for the community. But the problems that we're seeing is it's hard to integrate hardware just based on spec. There could be a great machine out there that provides value to the business, to the end customer. The end customers want it, but we cannot bring it in because security doesn't add up, because it cannot be managed at scale, or for other reasons that are not really tied to the differentiation that this the system brings in. So that's the one that we want to eliminate. So in order to do that, you need to get a better grip on the machine than just the spec. And if there's one thing to remember of what I say tonight is, it would be great if I had a piece of hardware that I can immediately test. But I can't really test it because I can't necessarily even understand what the firmware does or how it's organized and so on. And you may say, why? Isn't that a solved problem, right? You just install some firmware and then you run a test and so on. And this is where my second point in terms of problems comes in. The complexity of the systems has increased quite a bit. If I look at the machine that we use to sell GPUs in the cloud, it has multiple trays. The control story is complex. There are many tens of programmables in the machine, scores of programmables. So they even just writing them all or making sure that all the firmware is what we think it is, or controlling all the sensors and so on, doesn't just work. These machines are not, they don't live in a vacuum. They get an airflow from the outside. There's a power dimension to it. And they're built by several companies. We don't build everything. We buy devices from someone. We buy boards from someone else. Maybe we design them. Maybe we assemble. Maybe we buy the whole thing. So they're becoming very complex. You end up booting multiple OSs, running multiple firmware loops, and so on. So what's a better situation? A better situation is where there is a system that is open, and I could maybe buy with a credit card, and there's a software stack that I can install on it. And ideally, I can also modify it, so I can add value to it or customization. And this is all available for everyone to try. This would reduce the barrier to entry for non-differentiating issues. So so if I had the system and if I were able to express my requirements, then the requirements would be easier to understand. If I could express my requirements as tests, it would be easier for everyone, for vendors to understand and to say, oh, that's what you mean, that's what you need. Okay, maybe we can design for that. Or no, we cannot design for it. Or maybe we find a convergence to it. But today it's just not possible because, again, maybe I cannot install that firmware, or it cannot be signed, or it cannot be produced or repaired or so. There's just too much friction in the environment, and it's unnecessary friction. It's not good for vendors. It's not good for Google or other data centers. So, like I said, there are some problems to address, and I talked about the good end state, which is this. First of all, actually, before you even talk about firmware, you want to agree on architecture and modularity. If you see the machines completely different, it's going to be hard to align on anything. Everything is going to look like a snowflake. But if the machines look somewhat similar in terms of building blocks, then you can actually start to talk about how do you test them the same, how do you express requirements, and on what. And then, data centers, hyperscalers, edge, and so on can articulate their dependencies, their requirements. Some of them are going to be different. If you run a public cloud or if you don't run a public cloud, you will have different requirements. But that's okay. There are not 30 types. There may be 2 or 3 types, right? And we're hoping that, and you need some kind of reference software in order to power all this. And I emphasize on reference, this is not necessarily the software that everybody will use, but it is some software, some baseline that you can start from. And when you publish a system, you say, okay, this is my reference software, and it can be updated. You can go with something else. We're hoping that, so the vision here is that will tame the diversity. Otherwise, it's very hard. Again, if everything is a snowflake, a while ago it was fine. We had 2 or 3 types of snowflakes. Now we have 20, 30, 40. Okay, let's continue.
Right. So the main story here was we build one stack, one software stack, and on top of perhaps a representative hardware stack, but then be able to position it in multiple use cases, serving large data centers of enterprise, hyperscale, or edge data centers. So that was the main point. But then when we looked around, we saw a lot of people are working on this. Within OCP, we had a number of concurrent projects. System is a combination of hardware, security, management, telemetry, benchmarking. And there is a lot of good activity already going on within OCP. So we said, hey, might as well we take advantage of every one of them. And we've been talking to these project leads and project members. And you saw that perhaps on Monday, when Cloud Service Model was talking about these things, they did mention these concepts bottom up as they're defining the requirements for a data center top down. So the talk today is mostly around this DC stack, which is the data center ready integrated system, software on top of hardware. This is the staircase that you perhaps saw yesterday as part of Cloud Service Model. and today Mohan, just an hour ago, repeated the same. We started with defining a secure control module. That was the heart of the motherboard that 2 years ago we took out of the motherboard, separated DC-SCM from HPM, the host processor module. Interface was defined. That was called DC-SCI. That was the specification. We have contributed that to OCP. 1.0 is released, and people are working on 2.0. Tomorrow, there are 2 sessions on that, on both of them. Please join. And then on top of that, what we're about to do is to build a hardware system around the whole thing. So data center ready, modular hardware system is the specification that we're about to engage. And as Silvius has challenged us, we would like to overlay that with software, various ingredients for telemetry, benchmarking, diagnostics, security, RAS, all of that, infrastructure software on top of it. Then we call this system a DC stack. It's a data center ready stack that a supplier can build, test and validate, and place it into OCP Marketplace for people to order. That's what we're looking for. We're looking for contributions in different areas. So in doing that, we had to define a nomenclature, taxonomy of what we're trying to do. We looked at systems that people build. We have built some systems ourselves. Our colleagues from different companies have built systems in the past. It looks like there are 4 or 5 different major blocks. The control module I talked about, DC-SCM. HPM, the host processor memory module, that we articulated that one in 2019, OCP Summit. And then we have also contributed DC-XPI, the interface between HPM and modular I/O. That's also a specification contributed to OCP. It is on server project wiki. And we also recognize the existence of a smart NIC. Different people call it different things, IPUs, DPUs, but basically the networking function that is offloading infrastructure software. Overlay the whole thing or other aspects, RAS, telemetry, security. And for that, we had to come up with the terminology, and these are the nomenclature that we use, hierarchically defined. DC stack is the umbrella. Underneath that, we have software structure, so that is Hyperstack. And Silvius will talk a little bit more today, and we have a dedicated session tomorrow afternoon about the same hour about the software ingredients. In the morning, right at 8 o'clock, we will have conversation, deeper dive into the hardware, modular hardware system itself. But these are the ingredients that will go into that. And the software components.
Yeah, let's go over every box and
and then critique them and tell us which one of those boxes you will build.
So, well, I think some takeaways here are that the lines are, they need to be standards, right? So they need to be standard interfaces so that you can take these components and replace them. But you can start with some reference components, and then you can replace if you want to differentiate. The point is they need to be standard. If you don't use standard connectors and interfaces, then you're not going to be able to, we're not going to be able to integrate. So fast integration is actually extremely important, because once a product is ready, then it just sits on the shelf if it cannot be used. So I like to talk about this a bit, about the compliance suite, because I think this is what, and this is a vision right now, although we are developing lots of the ingredients, and this is a royal we, it's the community at large that is developing a lot of the ingredients. So these are what we call user journeys or requirements for integration in a data center. So basically, I can take perfectly good hardware and put it today and try to connect it to all the manageability and attestation and upgrades and so on infrastructure at Google, and it just won't work. Because the system could be complex, right? It could have maybe one smart NIC or maybe multiple smart NICs. Maybe it's a big accelerator machine full of GPUs and so on. And it needs to just work, right? If it doesn't report the right telemetry or so, it's not going to work. But how would a vendor know what to produce or how to test it? So we try to describe all these requirements as user journeys for the user of the hardware, right? And the user of the hardware, sometimes it's an operator that cares about power control and so on. Other times, it's somebody who cares about how to partition this hardware, right? So we have various resource management at scale at Google, various systems that do that, and they need to have the hooks in the hardware as well. And what we're looking for here is to describe this interface through tests and to publish these tests, of course, and to use OCP as a meeting ground where data center administrators, whether they are hyperscale, edge, or enterprise, can publish their requirements in a way that they can be understood. So I'm repeating this, but now you can see there are very specific conditions that need to be checked, and they can be expressed and validated.
And the fact that every company needs to do these things, and they are in fact doing that. It's just they're doing it in their own ways. And Google also has a suite.
So we've been doing this for, I don't know, 20 years, I guess, right? It's just that systems got very complex lately. So when you're building a two-socket machine with a particular CPU vendor, and then you go to the next two-socket machine with the same CPU vendor, it's okay, not much change. But when you go from there to a machine with 16 GPUs and multiple NICs and so on, many things change. And we've adapted, and now we have a methodology to build all this, but it's specific to our requirements and what we do. And we think that's suboptimal because it gets replicated in many places by many others. So we're looking at developing a system where this is what we call this flywheel of success, where such a system can exist in the open. And then it gives access to vendors that don't necessarily are in an active contract with us, right? And it helps everyone understand what is needed long term. And it allows other hyperscalers and edge providers to express their requirements as well.
Right, so we're basically going through a process of making sure these individual modules that are part of this large test suite that Sylvia's talked about are actually useful for others. And perhaps they can be taken out and replaced by other modules that are more important to others. So basically, there's a process that hopefully next year we can go through together with the community to open up the test suite, validation suite, diagnostic, security, RAS, all of that, so that at the end, we could have this open data center ready integrated system.
Yeah, one quick example here just to illustrate it, because this is all fairly generic, is imagine you just want to get telemetry, right? Temperature, fan speed, and so on. But you have a complex machine with many boards and so on. And which fan are you talking about, which sensor are you talking about, and so on. And you can do that over RedFish, and this is something that's existed for a while. But sometimes the schemas, the way you organize your system and so on is going to differ slightly. And some systems are going to be customized, right? And they're going to have maybe different schemas. And even though RedFish interface is presented, and even if our orchestration system makes RedFish calls, it doesn't mean that they speak the same language, right? Just speaking English doesn't necessarily mean that you're actually conveying something specific that is well understood. So now, if you have an acceptance suite, then you make RedFish calls, and everybody knows what calls you're making, right? And what output is expected. This is a very simple example. In reality, the situation is more difficult, but this is what I'm talking about. And I would assume, okay, there's an acceptance suite that is common to maybe multiple hyperscalers. But then there may be something specific to Google, and maybe 3 things that are specific to Google, maybe 1 for public cloud, 1 for other setups and so on.
Very good. So again, tomorrow there will be a number of other workshop sessions, technical deep dive into a lot of these topics. Please come and participate. We have already contributed DC-SCM 1.0, 2.0 is around the way. XPI is out there. We are working towards a modular hardware system and DC-Stack. This is in our journey for hopefully next year. Hopefully by Prague regional summit, we'll have a report out. And hopefully next year about this time for the global summit, we might even actually have hardware demonstrating some of these concepts. So before we leave, I wanted to leave you with this thought. As a young engineer a long time ago, I learned that the concept of quality means that the system kind of works. It just works. The customers expect quality for the things to work. But then if you collaborated with others, you added compatibility on the quality, it simply works better. That was the slogan that one of the companies used a long time ago. But then when we wanted to, as larger scale shipping into data centers, we learned that, well, it better simply work. Otherwise, a lot of people will be mad at you because a lot of people are relying on your servers. That was a server, not a desktop. It was a server. It was serving many, many, many companies. And now as part of a larger data center, I've learned that, man, if you want to take it to the data center at scale, it better simply work efficiently. And that's the major tenet of OCP, space efficiency, power efficiency, cost efficiency. And that's the work that we have in front of us as well. So with that, I'll leave you with some of these related work and beg basically for your contributions, for your feedback, for your engagement in various OCP projects.